Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And we are actually seeing the communication systems video lecture series. And we are in the fifth unit now, that is information theory and error control coding. And in this unit, we are going to discuss about the Huffman coding, where we discussed in a previous episode Shannon-Fano coding. It's similar like the Shannon-Fano coding only. So, some difference is there that we will see in this video. Come, let's dive into the topic. So, first, the agenda of this presentation is data compression fundamentals, information theory principles, and coding algorithms. That is detailed study of Shannon, Fano, and Huffman coding techniques and their applications. Then application and analysis. These are all the agenda of my presentation. So what is actually first of all, data compression? Data compression, why we supposed to know that the data compression means the Shannon-Fano coding or Huffman coding or some other coding methods, which is ultimately used to compress the media files, that is image, video or audio or like that, right? As I said in the previous episode, in a WhatsApp, instead of sending how are you, we used to write as H or U, and where are you, W or U. That means that saves the time and as well as the time saves the space also. So the memory requirement is less. So that is an example. Likewise, the data compression is important in communication purpose. So for ultimately to compress the data only, we are using these kind of a coding methods. So packaging your suitcase. Imagine packaging clothes for a trip. You want to fit everything in the smallest suitcase possible without losing anything important before compressing your compression. Your clothes are loose and fluffy, taking up lots of space in suitcase, just like raw data files, right? So that will be fluffy and that will be loose, right? So you cannot know put into the altogether into the suitcase. So we have to know fold it properly, and we have to give the pressure so that it will be settled down in the suitcase, and we can have a perfect package. So this is what actually done in the Huffman or Shannon-Fano coding, right? So before compression, there will be a the image that depicts no, it is like something random order, and after compression, it is like organized manner, right? So this is a very good example to understand the data compression. And the postal service analogy is another method. So rare words and big stamps. So uncommon words like X, Y, L, O, P, H, O, N, you get bigger stamps. They are used rarely in normal communication. Similarly to how rare letters get longer codes. Common words, short stamps. Popular words like the and get tiny stamps. They appear frequently in text documents, just like common letters needs short codes in Huffman. Information theory fundamentals. Shannon information theory includes that already we have seen, that is entropy calculation and source coding theorem and optimal compression. And the Shannon-Fano coding algorithm, which has four divisions. One is sort by probability. Another one is dive into groups. Third one, assign binary digits. Complete, and the final one is complete code assignments. So building the Huffman tree, how we can build the Huffman coding? That is a very important one. First thing, count and sort. Count is nothing but a count how often each letter appears, then arrange them from last to most frequent, like sorting students by height. Then building tree bottom up and assigning binary codes. Then verify optimality. The real world examples are H count, E count, L count, and O count. That is count letters. So if the count of the letters is highest one, then that will be give us highest priority. Likewise, we will be having such a kind of algorithm we can use for the Huffman coding. And Huffman versus Senan. What's the comparison? So Huffman advantage is guaranteed optimal prefix free codes always produce minimum expected length, mathematically proven optimal for symbol by symbol coding. Then performance metrics, Huffman typically achieves 10 to 20% better compression ratio And when comes for the Shannon Fano, it is a simplicity and the complexity analysis is advantage of your Shannon Fano coding, right? And why Huffman coding is amazing? That means everywhere around us. So use zip files and power image formats like JPEG compression algorithm, and makes internet browsing faster and smoother, and space saving magic. That is, as I said, it compresses the data between 20 to 90 percentage. So without losing data, so that saves the lot of space and keeps all the original data, and works like magic but follows strict mathematical rules and communication excellence. Essential for modern telecommunication systems, enables efficient data transmission over limited broadband. And performance analysis and application, some key performance are text files 85% of compression ratio with optimal performance, and image 65% efficiency often combined with each other technique, and database 75% of compression is possible in Huffman coding. So thank you for your attention, and we will get together in the another session. Thank you.